conditional probability. So the way we read this is probability of B given that, that's what the bar means, given that A is happening. And so if given that A is happening, for sure that probability of A has to be the denominator. So if I just multiply through here, this P of A and B is going to be the probability of B given A times the probability of A. All right, let's look at this example with discrete math, people. All right, so we've got two tests, 25% received an A on the first test and 15 on both tests. So let's see what they're asking. What percent of the students who received A on on the first test also received an A on the first test? I'm sorry, on the second test. I read that wrong. What percent of the students who received A on the first test also received an A on the second test? So that means I'm looking for the probability of A on the second test given that they got an A on the first test. So there's no necessary notation for this. You just need to figure out what they're asking. So the given that is the A is on the first test. All right, so what that's going to turn out to be is that I got a probability of A on both tests, right? So I can just write A on both tests, divided by, and the given condition is this, right? The probability of A on the first test. Okay, so let's look back at the information we've got. Who got an A on the first test? Oh, that was, received an A on the first test was 25%. So that's the denominator. I'll just write it as 0.25. And then who got an A on both tests? Oh, that's right. That's the 15%. So that gives us 0.6. So that's the number of people who got an A on the second test, given that they got an A on the first test. All right, so let's look at this one. So a couple has two children, and you know one is a boy. Okay, what's the probability the other is a boy? It says nothing about order. So if I write down all the different combinations for the two children, here I have them. Okay, so there's 3 of the 4 possibilities give me a boy, right? So what I'm looking at is the probability is the other is a boy given that one is a boy. You can't say the second or the first because it doesn't matter the order. So that means the probability of both are boys divided by the probability that one is a boy. So both are boys. That's going to be only, well, that's just one of those 4 cases. So that's where that comes from. And then one is a boy. Well, that's going to be the 3 out of the 4 cases, right? That has the one boy. So that gives me a 1/3. All right, let's dig into this one. That's talking about a set of die. So we're looking at a blue and gray just to make sure you distinguish that there's 2 separate die. What's the probability that the sum of the numbers showing up is 8? All right, well, let's just write down all the combinations that we can have with the sum of 8. So I'd have a 4 and a 4, and a 5 and a 3, and a 3 and a 5, a 2 and a 6, and a 6 and a 2. So I see 5 different things here. Okay, what else are they asking me to contrast with? Both numbers are even. So both even. Let's think about it. So all, doesn't matter what they add up to, right? So 2, 2, 4, 4, 6, 6, 4, 6, 6, 4, 2, 4, 4, 2. Okay. So now let's look at what we're going to be trying to solve for. So I want the probability that the sum is 8, given that, so probability, the sum is 8, given that they're both even. All right, let's break that down. So that means the probability of sum of 8 and both even. And then the given that is the denominator, probability of both even. Okay, so probability of both even, well, let's check it out. How many different cases do I have here? So 1, 2, 3, 4, 5, 6, 7. Oh, did I write them all out? 1, 6, 4, 4, 2. I wrote down I had 9. 1, 2, 3, 4, 5, 6, 7. Hold on. Is there another even case? 2, 4. Yes, I'm missing the 2 and 6 and 6 and 2. Okay, so there are a total of 9 cases out of the 36 that are both even. And then how many of the cases when there's sum of 8 are they both even? 1, 2, 3. So I have the 3 out of the 36 from the numerator, multiplying by the reciprocal, I get 1/3.